Okay, now let me continue the lecture on designing columns subjected to combined bending and axial loads. As you know that the one that I've done before is only dealing with column with axial loads. So again, let me look at the failure mode. This time around is with the presence not only the axial load here, but also there is a moment. For example, here the first case is the moment is on the minor axis, which is on the z-axis, and whereas this one here, the moment is subject uh, on the y-axis, and here the y-axis here, and this one here, both having bending at the z-axis and also at the y-axis. And another type of failure is there is a moment at the z-axis, and there is also a moment at the bottom of the column here, and again there's a moment at the top on the y-axis, and at the y-axis at the bottom, and the third one is the biaxial moment, both having at the top and also at the bottom in both axes. So these are the type of failure that could happen for the column subjected to combined bending and also axial load. It is more complicated than designing column with axial load because of the presence of the moment. Now let me just explain basically the type of failure, the buckling axis here. Now this is MZT, meaning to say that this is the moment at the T is the top at the Z axis. So why this is a Z axis? So it is actually based on this particular axis there. So this is actually Z axis, and this one here is the Y axis because it's based on this particular axis. So that is still Z, but Z, and this is Y axis. Then there's the reason why it is moment at the Y axis. So it really depends on how where is the load is being applied. So for example here, if there is a load here, so and there is an axis here, this is actually the eccentricity E, and that will cause the bending on this particular axis, which is actually Z and Z. Okay. All right. Now, the design process is very much complicated for columns subject to axial load and bending, and it has to follow through this process. Look at the compression, calculate the design resistance NCRD first, and compare with the one which is similar to the before. And apart from that, we need to check also the design resistance for bending, which is MCRD, which is quite just similar to the one in the beam design. But for bending and axial force, in this case, you can see how complicated is the formula here, and also another one is for uniform bending compression, as well as uniform bending in compression. You can see that the formula is very complicated, and again column subjected to axial load and bending, uniform members in bending and compression. It's not that straightforward to follow through all this formulation. So as such, we are fortunate in this case because in our design class, we only the scope is only for column with simple construction, meaning to say that The beams are designed as simply supported. The columns are designed as a nominal moment arising from the eccentricity. So for the case of this course, we only concentrate on beam with simple construction only. As such, it allows us to use a simplified formula. This formula here, and we can avoid using all the formula as referred above. So I will explain later how are you going to use this formula in the next lecture. Okay, bye. Thank you.